What I want to do in this video is familiarize ourselves with the idea of really treating units like algebraic quantities. So let's just take probably one of the most common formulas that you see. Distance is equal to rate times time. Rate times time. So let's say that your rate is given in terms of kilometers per hour. So let's say that your rate is 10 kilometers per hour, and that your time is given in terms of hours. So times 2 hours. So in this situation, we say our distance is 10 kilometers per hour times 2 hours. And what's neat about this, as I just mentioned, is we can treat the units like algebraic quantities. So we can look at the numeric part. So you have 10 times 2. We're just multiplying a bunch of things. 10 times 2, so let's put our numeric quantities out first. 10 times 2, and then let's think about our units. Times kilometers per hour times hours. Times hours. The hours are in green. Times hours. So if we treated whatever, this km, which we know is short for kilometers, if we treated it as an algebraic quantity, if we treated it almost like a variable, if we treated h like an algebraic quantity, then what's going to happen here? Well, we have an h that's going to be in the numerator and an h in the denominator. These two things would cancel. And so what would we be left with? Well, we would be left with 10 times 2, which is equal to 20. And then the only units we would have left are the kilometers. And this makes complete sense. Our distance is going to be 20 kilometers. The units also worked out. Now let me give you another example. Let's say that instead of kilometers per hour and hours, let's say that someone were to give you your distance, or let's say they were to give you your rate in terms of, let's say they were to give you your rate in terms of kilometers per second. So this is actually quite fast. 10 kilometers per second is extremely fast. And then they say, and you've gone 10 kilometers per second for, let's say, 3 hours. So just looking at this, could you think about what your distance is? Well, you could say, well, let's see. I can multiply 10 times 3 and get 30. But then I'm going to have 30 kilometer hours per second, which is kind of strange. Actually, let me just do that just to show how strange that is. So if I took the 10 and the 3, if I multiplied those two, I'd get 30. But then I'd be left with kilometers times hours. Once again, I'm just treating the units like algebraic quantities. Kilometers times hours per second, which is really strange units here for distance. So what I really would want to do is somehow make these hours and these seconds cancel out. And this is salvageable right over here. I could do that. If I were to write something that has seconds in the numerator, and hours in the denominator, I could actually salvage this thing. But I can't just write seconds. I can't just write something arbitrary like this. I have to actually write something that makes sense. So I could write in terms of how many seconds do I have per hour? Well, I know that I have 60 seconds for every 1 hour. So this is equivalent to multiplying by 1. 60 seconds is equivalent to 1 hour, so you could kind of view this as not changing the quantity. I'm multiplying by 1. 60 seconds is the same thing as 1 hour. We know that 60 seconds is equal to 1 hour. So if you divide both sides by 1 hour, you get 60 seconds over 1 hour is equal to 1 hour over 1 hour, which is equal to 1. So we're just multiplying this thing by 1. And why is this useful? Well, once again, we can treat the units like algebraic quantities. Seconds cancel out with seconds, hours cancel out with hours, and we're left with 30 times 60, which would be 1800, and we're left once again with the kilometers. So the important takeaway here, and this is a big one, this is useful not just in algebra, it's useful in physics, it's useful in chemistry, it's useful in the rest of your life, is that you can work through the units like they are algebraic quantities. And this is really, really, really useful to, one, do an error check to make sure that you're getting the right units on the other side of things, or to make sure that you need to convert units if necessary. Or oftentimes, especially as these formulas, as these equations get more complex, to even get an intuition of what is being described by the different variables or the different parts of these expressions.